Hello, good evening, everybody. And today I want to explain a problem which is related to inverse Laplace transformations. And here, this problem is related to inverse Laplace transformations. And in finding inverse Laplace transformations, here we are going to take the help of partial fractions. That means, if you look at this problem, find L inverse of s square plus s by s square plus 1 into s square plus 2s plus 2. And here, first take this term which is inside L inverse, which is s square plus s by s square plus 1 into s square plus 2s plus 2, and convert it into partial fractions, because if we have this kind of multiplication inside, it is difficult to find the inverse Laplace transformation. So we should have summation of sum of the two terms, or subtraction of two terms you need to have inside. Then easily we can find the inverse Laplace transformation by converting into 2. First I am taking this term which is inside L inverse, and now consider for this, to find the L inverse of this problem, considering inside term which is s square plus s by s square plus 1 into s square plus 2s plus 2, that is equals to, two factors are there. You should have the knowledge regarding partial fractions. Two factors are there, s square plus 1, s square plus 2s plus 2. Hence I am converting into two partial fractions, in which one is related to s square plus 1 and another one is related to s square plus 2s plus 2. And now here, already if you have minimum idea regarding partial fractions, if you have in the denominator second degree term, we should have in numerator s term and constant term, and we need to have a constant coefficient for s. You will have this kind of term in numerator, as plus b by s square plus 1 plus cs plus d by s square plus 2s plus 2. Now next, take the LCM on both sides, cancel the LCM. This side s square plus s you will have. This side s square plus 1 into s square plus 2s plus 2 is the LCM. By cancelling s square plus 1, you will have as plus b into s square plus 2s plus 2 plus cs plus d into, by cancelling s square plus 2s plus 2, you will have into s square plus 1. And now main thing is finding this a, b, c, d values. And now this side s square plus s equals to, multiply s plus b with this, the three terms, multiply cs plus d with these two terms s square plus 1. You will get s square plus s equals to s into s square, s cube plus s into 2s, 2as square plus as into 2, 2as plus bs square plus 2bs plus 2b plus, and now I am going to convert these two terms with these two terms, cs into s square, cs cube plus cs into 1, cs plus d into s square, ds square plus d into 1d. And now s square plus s equals to as cube, cs cube. These are all these two s cube terms, 1, 2, 3. These three are s square related terms, 1, 2, 3. These three are s related terms, 2b and d. These two are constant related terms. S square plus s equals to a plus c into s cube. And from these three terms, take s square as common, 2a plus b plus d into s square plus. From these three terms, take s as common, 2a plus 2b plus c into s plus. Two constants, 2b plus d. Like this in RHS, write s cube term, s square term, s term and constant term. Now this term we don't have s cube term, therefore s cube quotient will be 0, s square quotient will be 1, s quotient will be 1, constant term is 0. Compare s cube, s square, s constant coefficients, because we have equal sign. Two terms equal means s cube quotient will be equal, s square quotient you can equal, s quotient you can equal, constant terms you can equal. Hence by comparing s cube, s square, s constant coefficients, we get a plus c, this side s cube coefficient is a plus c, this side s cube coefficient is 0. This side s square coefficient 2a plus b plus d, this side s square coefficient is 1. This side s coefficient 2a plus 2b plus c, this side s coefficient is 1. This side constant 0, this side 2b plus d equals to 0. And now main aim is we have to find ABCD values from 2. You can, if you have idea on solving these, I have different ways of solving this. Main thing is we should find ABCD values, and now we can take whatever way. First we find ABCD values, and now here I am giving two ways. One way is this, and one way is normal way of finding ABCD. From 2 I have found c equals to minus a, and from 5 I have found d equals to minus 2b. I have substituted this c value minus a in 4. From 4, if you substitute c equals to minus a, 2a minus a, 2b minus a, 2a minus a plus 2b equals to 1, you will get this equation we have. From the substitute d equals to minus 2b in 3, d equals to minus 2b, that means b minus 2b minus b, 2a minus b equals to 1. And now this is wrong, and here I'm writing, let us take this one as another equation, and I'm going to multiply this equation with 2. This is wrong, and now I'm going to multiply this equation with 2. What will we get? 2a plus 2b, 2a plus 4b equals to 2. Because we have 2a here, 2a minus 2a minus minus minus. Solving equations, 2a minus 2a cancel, minus b minus 4b equals to minus 5b, 1 minus 2 minus 1b equals to minus minus cancel 1 by 5. Substitute this b, and we get b value. Substitute this b value in 5. From 5 if you solve, d equals to minus 2 by 5. Substitute this bd values in 3. In 3 you will get a value, which is this. Substitute these values. A value you got from 2. If you solve, a equals 3 by 5, c equals to minus a, that means c equals to minus 3 by 5. ABCD values I got. Otherwise this is another way of finding these 4 values. But if you have idea on matrices, the way is write solving these equations. 1 we have non-homogeneous, in the place of x y z w we have a b c d we have. And now from related to this system of equations, I have written augmented matrix. First coefficient 1, and now b coefficient is 0, c coefficient is 1, d, we don't have d term, d coefficient is 0, this side term is 0. Like that 4 equations. If you look at last term, a coefficient is 0, b coefficient is 2, c coefficient we don't have term 0, d coefficient is 1, and last coefficient at that side constant term is 0. Augmented matrix, this is called. Convert it into echelon form. This is echelon form we have, and after converting into echelon, this method is called Gauss elimination method. And here by writing again equations, we have this a term, b term, c term, d term, d term, a plus c equals to 0. From last equation you can find last variable d value minus 2 by 5. Here also minus 2 by 5 you get. And by substituting, by solving the remaining 2 to 1 equations, 3 to 1 equations, you can find c, b, a values. And after finding these 4 constant values a, b, c, d, and substitute these 4 values in 1. This is the one. In 1, a, b, c, d. And now I'm continuing this problem. And now this is the problem we have. Continuation. From 1, s square plus s by s square plus 1, s square plus 2s plus 2 equals to as plus b. A is 3 by 5, s plus b is 1 by 5 by s square plus 1 plus cs plus d. C is minus 3 by 5, d is minus 2 by 5. And now after converting like this, 2 terms plus 2 terms addition, here 2 terms subtraction, we need to have 2 terms addition like this, 2 terms. Apply L inverse on both sides. L inverse of this 2 terms L inverse means convert into 2 L inverses. L inverse of this plus L inverse of this. And now I am going to continue this. Again, a plus 2 terms by single term. This one by this one plus this one by this one. And that means this one by this one, 3 by 5 s by this one means apply, if you apply, divide into 2 L inverses. 2 L inverses. L inverse 3 by 5 I am going to take as constant, which is constant I am going to take out. L inverse of s by s square plus 1 you will have plus this plus 1 by 5 is constant. I am going to take out L inverse of 1 by s square plus 1. I have converted into 2 terms and I have converted into 2 L inverses plus 2 terms by single term. Treat that one. Treat this one as single term. This one by this one. This one by this one. That means minus 3 by 5 is constant. I have taken out L inverse of s by this one minus 2 by 5 is constant. I have taken out L inverse of 1 by s square plus 2s plus 2. S by for first term, this is the one you will have a second one. And now, from now, the main thing is solving this 4. 1, 2, 3, 4 L inverses. 4, that means we have in this part 4 problems. And here, first 2 parts are easy. That means we need to have idea on L inverse related formulas. 3 by 5. L inverse of s by s square plus a square. The formula is, I am going to show that formula we have. This formula I am going to use. L inverse of s by, if you have s by L inverse of s by s square plus a square, cos a t is the formula. In the place of s square plus 1 we have 1 square you can write. 1 square you can write. Therefore in the place of a we have 1. Therefore the formula will be 3 by 5 into for this cos a t. Cos in the place of a what do we have? 1. You can write this one as 1 square. You can write this one as 1 square. You can write this one as 1 square. That means cos a t is the formula. For second one, 1 by 5 into L inverse of 1 by s square plus a square you have. If you have L inverse of 1 by s square plus a square, formula is sin a t by a. That means here we have sin, in the place of a 1 we have. That means what is the answer? 1 by 5 into sin a t, sin 1t. What is a? 1 t by 1 means sin t by 1 means sin t minus. And these 2 parts are easy comparing to these 2 parts. And in these 2 are like 2 more problems. Minus 3 by 5 into L inverse of, if you have this, can look at this denominator. You have s term here. If here we don't have s term, constant term, s square term, constant term. But here along with s square and constant in middle we have s term. Therefore we have to use a different procedure. And here minus 3 by 5 into L inverse of what do we have? 2s we have. And here in this case, if you have s square term, s term, constant term, if you are able to write this as factors, we can convert this one. If you are able to convert this one as factors, we can convert this one factors, convert this into factors, and by using partial fractions we can complete L inverse. But here it is difficult to convert this one as factors. Therefore here take these 2 terms, s square and 2s, take these 2 terms s square and 2s and write this s square plus 2s as a whole square term, a plus b whole square plus constant, or a minus b whole square plus constant, like I am doing next. And I am taking this term minus 3 by 5 into, I have completed first 2 terms, this minus 3 by 5 into L inverse of s by, keep the numerator same, s square plus 2s I am writing as, let us imagine s square as a square, that means where a is s, right? That means I am going to write this s square plus 2s as, I am going to use a plus b whole square formula, which is a square plus 2ab plus b square. And here since it is I have compared this one to a square, where a is s, where a is s, that means I have written next term as 2ab term. 2, where is a, since a is s, 2a, since we have 2s, that means here b will be 1, 2s into 1, 2ab. If you compare with 2ab, b is 1, that means we should have here a square plus 2ab. That means we should have, if you want to write this part as a plus b whole square, we should have b square, which is here b is 1, that means we need to have 1 square, that means 1. I have written 1. To get the equality, here we have 2, that means I am writing 2 as 1 plus 1. The 1 is I am sharing for b square, and another 1, keep the 1 here, and I am converting like this. And next this here s by, and same changes I am applying minus 2 by 5 into ln inverse of 1 by, same changes I am writing here. And now 3 by 5 into cos t, 1 by 5 into sin t, that is completed, minus 3 by 5 into ln inverse of s by, from this term to this term, a square plus 2ab plus 1 you can write as 1 square, where b is 1, you can write s plus 1 whole square, remaining is plus 1, minus 2 by 5 ln inverse of same, from this term to this term you can write s plus 1 whole square plus 1. And now 3 by 5 into cos t plus 1 by 5 into sin t minus 3 by 5 into, after writing this, why I am writing this, because I want to use first shifting property. And if you have ln inverse of capital F of s plus a, the formula will be e power minus at into, immediately I will replace s plus a by s, that means ln inverse of f of s. I am going to use this. And here we have, look at this term, s is here, s plus 1 whole square plus 1 is here, that means you can say this term is in terms of s, but you cannot say this term is in terms of s plus 1. If you have in the place of s also s plus 1 we have, if you have here in the place of s plus 1, s plus 1 by s plus 1 whole square plus 1, that means everything will be in terms of s plus 1. You can say this term is in terms of, this is a function in terms of s plus 1, but here we don't have s plus 1. Therefore to get the function in terms of s plus 1, where a is 1, I am trying to get here s plus 1 in the place of s. Simply s plus 1, add 1, subtract 1 to get the s plus 1. That is the only reason. Minus 2 by s, ln inverse of 1 by, this is already in terms of s plus 1, because we have s plus 1. This term we can say in terms of s plus 1. And now here we should get used to this term. What is in terms of s plus a? What is in terms of s minus a? For example, if I write s plus 2 by s plus 2 whole square plus 5, you can say this term is in terms of s plus 2, since we have s plus 2, since we have s plus 2 here. For example, if we have s by s plus 2 whole square plus 9, you can say this is in terms of s. This is not in terms of s plus 2, because here we have s plus 2, but here we don't have s plus 2. Here also you should have s plus 2. And if you are able to understand this, you can make the changes. 3 by 5 cos t plus 1 by 5 sin t minus 3 by 5. S plus 1, treat s plus 1 as one term, minus 1 as another term, convert into two terms. This s plus 1 by this one, s plus 1 by s plus 1 whole square plus 1, and multiply 3 by 5 and apply ln inverse. And minus, I am converting two terms, minus into minus, minus plus 1 into 3 by 5, 3 by 5. That means what will we have? Minus into minus plus 3 by 5 into ln inverse of 1 by s plus 1 whole square plus 1, minus 2 by 5 into ln inverse of 1 by s plus 1 whole square plus 1. Both terms are same. 1 by s plus 1 whole square plus 1 ln inverses both are. Here the coefficient is 3 by 5, minus into minus plus 3 by 5. Here the coefficient is minus 2 by 5. 3 by 5 minus 2 by 5. Take the ln inverse of 1 by s plus 1 whole square plus 1. Write one more step in rough. And 3 by 5 minus 2 by 5 means, if you take LCM 5, 3 minus 2, 3 minus 2, 1 by 5, you will have 1 by 5 ln inverse of 1 by s plus 1 whole square plus 1. Here instead of two terms, by taking ln inverse of 1 by s plus 1 whole square plus 1 as common, I have converted into one term. Now 3 by 5 into cos t plus 1 by 5 into sin t minus 3 by 5 into Here this is in terms of f of s plus 1, in terms of s plus 1, and if you compare this one, a is 1, and immediately multiply with e power minus at, where a is 1, therefore e power minus 1t I have multiplied with, since we have this is in terms of s plus 1. Immediately after multiplying with e power minus t, replace s plus 1 by s. L inverse of s plus 1 in the place of s plus 1 s, in the place of s plus 1 by s whole square plus 1 plus 1 by 5 into, again this is in terms of s plus 1, multiply with e power minus 1t where a is 1, and immediately replace s plus 1 by s, 1 by s square plus 1, and now 3 by 5 into cos t plus 1 by 5 into sin t minus 3 by 5 into e power minus t. Now in the place of this you can write cos t plus 1 by 5 into e power minus t into, in the place of this you can write sin t. This is the answer. And that means like this, if you have idea on inverse Laplace transformations formulas and partial fractions, this is important topic where to find inverse Laplace transformation we are taking the help of partial fractions. And here main thing is how to convert the term into partial fractions. If you able to know that 70% problem is converting into partial fractions, then you need to have idea on solving inverse Laplace transformations after converting L was applied and 4 terms. And here how to, if you have idea on finding inverse Laplace transformation for these 4 parts, that is enough. These two are enough. These two are direct formulas we have, and here these two are converting denominator. If you are able to convert denominator into factors, then by taking the help of partial fractions you can find this. But here we are unable to convert this s square plus 2s plus 2 into partial fraction. That's why I have converted this term into this term. And here this is important, L inverse of f of s plus a. That means if you have s in terms of s plus a, immediately you can multiply the e power minus at. If you have in terms of s minus a, you can multiply the e power at, and immediately you can replace s plus a by s, L inverse of f of s. Later you can solve this. This answer we have. Thank you.